Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence. I'm really excited for today's discussion because we have such a fascinating range of perspectives, and we're going to be diving deep into where the field of AI is headed.
Yeah, I'm buzzing to get into it. I feel like we're at such a critical point. There's so much happening so fast, it's almost hard to keep up. It's definitely going to be interesting to hash out where everyone thinks the real breakthroughs are.
Agreed, it's certainly a dynamic field. And yeah, critical point is a good way to put it. I guess I'm also excited, but with maybe just a little bit of skepticism mixed in.
Skepticism is healthy, I think. I mean, we've seen so many hype cycles. But yeah, the speed of things is definitely something. So I'm eager to really dig into what we actually know versus what we're just hoping might be true. Let's get into it.
All right, so I think a good starting point might be to discuss some of the recent news or, notable papers that have caught our attention. There's been quite a bit happening in the last few months.
Absolutely. Okay, well, for me, I've been glued to the developments in the scaling of large language models. I mean, some of the latest iterations of those things are pretty jaw-dropping. I saw that paper, the one from DeepMind, where they're starting to get true emergent abilities, like models that are doing things that weren't explicitly programmed in. They're beginning to generalize in ways we didn't anticipate. Right, but isn't that just a symptom of needing more data, though? I mean, if you train that model on a much larger data set with variations in color, shape, and orientation, then wouldn't it be able to generalize just fine? The DeepMind paper did show those models were becoming more robust in this sense the larger they got. It was like the sheer scale of the data was forcing it to internalize a more generalizable representation.
Yes, exactly. That's what I'm getting at. This is where the neuro-symbolic approaches could come into their own. Think about how we learn through abstraction, using symbols, concepts, and logical reasoning alongside pattern matching. I think that could provide the kind of generalizability that these purely deep learning models lack. They need a higher level of abstraction rather than just learning pixel correlations, like the understanding part is missing.
I think both of you are onto something there. I do agree with you that brute force isn't the way, and just scaling data doesn't seem to address the core problem we have. I think it's a representational issue. It's about the fundamental encoding of the information. I'm really interested in how spatiotemporal information is being processed by the brain. It's not just about static data or sequences like language. I think the way the brain represents and transforms information through time is crucial. The models at the moment don't seem to have any concept of this. They're just processing each frame or token in isolation.
Right, and that's where the neuro-symbolic approach makes sense. Because it's not just about connections between nodes. It's about representing the world symbolically, using logic, reasoning, and rules. Think of a child learning about cats and how that develops over time with abstraction. If they see a black cat, they don't just see black cat. They internalize an understanding of what a cat is with certain features: fur, pointy ears, four legs. Then that concept can generalize to all cats, even if they're not the same color. That kind of abstraction and symbolic representation is what's missing in purely deep learning models. And the neuro-symbolic approaches blend that symbolic processing with the connectionist learning to make use of the strengths of both approaches.
Exactly. I think we are too focused on the connections between the nodes and not on how the information is represented and transformed. The brain doesn't just compute, it actively transforms the way information is being encoded. It doesn't just process sensory input. It actually predicts what that input is going to be. Predictive coding is absolutely key, and current neural networks are poor at implementing this at the level our brains do. We need to understand better how the brain translates information from the sensory level, vision, sound, touch, to a higher level, more abstract representation that can be manipulated and reasoned with. Then that representation can be used for internal world simulations. I suspect the key to AGI is in that transformation process and the way it can translate between different coordinate representations. Deep learning models are too inflexible and just not general enough.
But isn't that predictive coding just another statistical prediction at the end of the day? I mean, we see that in the current models. They are constantly predicting the next token or the next frame in a video. We are already on the right path, and we're seeing that these predictions are getting better and better. And to the point of transformation, the models are transforming the representations as they go deeper in the network. It's not as if they're just linearly processing information. The hidden layers are changing the representations, and it's that's helping these models to build that high-level knowledge. We shouldn't dismiss that so readily.
Yes, it's true that they are predicting, but it's not the same as how the brain is doing it. When the brain predicts, it's using a model of the world, and that model is not just a collection of statistical probabilities. It's a structured, hierarchical representation of the world, and these models are actively being used to generate predictions, and the prediction errors are being fed back to update the internal model. It's an active process of simulation. In deep learning, it's just predicting what comes next from a string of tokens with no real understanding of the underlying process. It's not actively using an internal representation to predict.
Right? And this is why things like common sense and intuitive reasoning are so hard for these models, because they don't have that structured, knowledge-based framework and the ability to simulate scenarios in their mind. They can do statistical inference based on the training data, but not causal reasoning or counterfactual thinking that human intelligence depends upon. This statistical inference is just a byproduct of an underlying knowledge of the world. And deep learning is trying to learn a byproduct directly without ever learning the underlying representation, which is why these models often fail so spectacularly.
Yeah, that's a really good point about counterfactual reasoning. The ability to simulate alternative scenarios is critical to understanding the world and predicting what will happen. These models just don't have that inherent ability. They might be able to do a what-if style of reasoning if it's in the training set, but it doesn't have the underlying framework to change the scenario and then run the internal simulation. It's not just about getting the right answer in the training data. It's about actively manipulating the underlying simulation and seeing how the model reacts. And I think that ability comes from a true sense of how information is represented in time and in different coordinate frames.
Okay, so where do we go from here then? If deep learning is not the sole answer and the neuro-symbolic approach has some merit, and the spatiotemporal representation is a key piece, what should we be focusing on in the next wave of research? It's not enough to just say deep learning is not the answer. What are some concrete things that can be investigated further?
I think it's clear. We need more research into biologically inspired AI. We should be looking at how the brain encodes information, how it learns, and how it makes predictions. We need to move away from just creating bigger and bigger neural networks and focus on architectures that more closely resemble the brain's own structure and mechanisms. For example, investigating hierarchical processing, recurrent neural networks, attention mechanisms, and predictive coding. We should also be exploring new learning rules that are more biologically plausible. There's a lot we can learn from neuroscience. The brain is the only example of truly intelligent system we know, so we should really take it seriously.
I agree, and I would add that we need to develop more robust neuro-symbolic systems. We need to combine the pattern recognition abilities of deep learning with the symbolic reasoning abilities of logic and knowledge representation. We need to focus on building AI systems that can understand the world at a higher level of abstraction. That includes being able to integrate different sources of information, do common sense reasoning, and make logical inferences. There's a really rich field of research here that hasn't been explored fully. We have all the pieces of the puzzle. We just need to learn how to put it together. I think that is the key difference between current AI and AGI.
And I think we need to focus on the spatiotemporal aspect of information processing. We need to figure out how the brain represents and transforms information through time and across different coordinate systems. We need to build models that can actively predict what's going to happen by using the internal world models and simulation. This means looking more closely at the neural mechanisms underlying perception, action, and the coordination between the two. We should be looking into how the brain represents dynamic scenes and translates visual information to motor commands. This is critical for a truly embodied intelligence. It's not just about processing data, it's about having an embodied representation of the world, and current models are simply not doing that at any level.
Okay, so that's definitely a lot to digest. While I still believe that the current path of deep learning is the correct one, I do concede there is lots of room for improvement. So I think we need to continue to scale up these models, of course. But I also think we should be investigating ways to build more robust representations. Maybe that involves incorporating some of the feedback mechanisms that have been mentioned and trying to get these models to not just blindly learn data patterns. We need to try and get these models to understand the world in a more generalizable way, and that could involve exploring more complex architectures or data augmentation strategies. We might even need to consider incorporating some of the symbolic reasoning capabilities into the deep learning framework. I think the next 5 years are going to be really interesting, and we will see some massive jumps in performance if these avenues can be explored further.
Absolutely. And I think that while we all have different perspectives, we all agree that the future of AI is not just about bigger data and bigger models. It's about understanding the fundamental principles of intelligence and incorporating those principles into our algorithms. And that requires a truly multidisciplinary approach involving neuroscience, computer science, psychology, and even philosophy. And that's why I'm so optimistic, because the research that's happening now is so interesting and there's huge scope for the next phase. I think we are going to see some really exciting things happen.
Yes, I couldn't agree more. And we also need to be really cautious about the ethical implications of AI. These systems are going to have a major impact on our society, and we need to make sure we're building them responsibly. We can't just focus on the technical aspects, we need to be thinking about the societal impact as well. And it's only through these types of discussions that we can hope to come to some type of consensus.
Yeah, definitely. And I think by focusing more on the fundamentals and looking at the core of how intelligence works, we stand a better chance of actually creating systems that are truly beneficial for humanity, rather than ones that just replicate some of our biases or problems. And I think if we can agree on these core issues, then we are moving in the right direction. And if we can agree to disagree on the methods, then we stand to gain from all perspectives. And that's why this type of conversation is so important.
Well said. I think we've covered a lot of ground today, and it's always fascinating to hear other people's perspectives, and I think we all agree that this is an incredibly exciting and complex time for the field of AI. And that's where these open discussions are so important. It's all about finding the right way to combine all of our ideas together into a more coherent way of moving forwards. The main thing is that there are so many avenues to explore, and we should all keep an open mind when it comes to these complex research topics. I think there's a lot more research to do before we can really crack this AGI problem.
Absolutely. I think that's a perfect way to end the discussion. Thank you all for your insights. This has been a really thought-provoking conversation. And, it just highlights how much more we need to explore and discover.